Hello and welcome back to the second section of these notes here. So yesterday we talked about how to do operations with vectors, add, subtract, and scalar multiplication, meaning just basically multiplying by some constant that makes it longer or shorter. All right. So another important concept with vectors is something called a unit vector. Okay, so a unit vector, just like you think like a unit circle, is a vector with a magnitude of 1. Now, these are important because unit vectors, so let's pick any vector. Let's say I have this vector right here. This vector has a magnitude, right, and a direction. Now, the direction can be represented either by a slope or by an angle, but it has both. It has a magnitude and a direction. What a unit vector does is it takes the magnitude out of the equation. It says, okay, well, let's just assume that the vector is 1. It has a magnitude of 1, so that the only thing that is of importance of this vector is the direction that it's moving. So that's why unit vectors are important. They're used quite a bit. Now, think about how we'd find a unit vector. Well, let's think about this first vector. Let's say that this has a magnitude of 3. Well, what would I have to do with this vector to make the unit vector? Well, you divide by the magnitude, right? If you divide by the magnitude, then you can make it have a magnitude of 1. So any unit vector, if I want to write a unit vector, all I have to do is, I apologize, I don't know what happened with my computer, is think about the unit vector is the initial vector, but it's divided by whatever the magnitude was. It's divided by however long it was, and that'll make it so that it has a length or a magnitude of 1. So, a couple examples here. First one, this first vector is negative 5, 12. So negative 5, 12, we have, first we want to find this magnitude, because that's what we're going to have to divide by. So it's going to be the square root of a squared plus b squared, which is square root of negative 5 squared plus 12 squared. I'm writing kind of small because I'm going to need the space. 25 plus 144 is 169. So the square root of 169 is 13. So let's write down what the unit vector is going to be. Well, the unit vector is going to be both of these divided by whatever the magnitude is. So it'll be negative 5 over 13, comma, 12 over 13. There we go. So there is the unit vector. Now, again, the idea of a unit vector is this vector is exactly 1 long, but it's going in the exact same direction as that vector. Okay, so that's kind of the concept here. So let's do the second example. So we want to know the magnitude of n. All right, so magnitude of n, we have square root of 9 squared plus 12 squared. Well, 81 plus 144 is 225, I believe. Let me get my calculator out here. Bless me. 225, which the square root of 225 is 15. So the magnitude of this vector is 15. So if I want to know what the unit vector is, it's going to be 9 over 15 and 12 over 15. Now, we know that's going to reduce. You can divide all those by 3. So let's just reduce that. 3 over 5 and 4 over 5. Okay, notice the positives and negatives won't change, and the reason is because it has to be going in the same direction. So if this is going into the second quadrant here, negative 5, 12, this also needs to be going into that second quadrant. So always just make sure your signs are matching for these unit vectors. All right, next one, magnitude of p. Now I'm going to do this kind of quick. So it's going to be the square root of 16 plus 1, which is going to be the square root of 17. Okay, You can do that using the whole formula, but that's what we have here. I want to save a little bit of space here, but that's what the magnitude of p is going to be. Now, to find the unit vector, you divide both of those by that. So it's going to be negative 4 over square root of 17, comma, negative 1 over square root of 17. Now, we know we can't leave it like that, right? You have to multiply everything by that denominator just to get it out of there. So it's going to be negative 4 radical 17 over 17, and then negative square root of 17 over 17. If you want to write the 1 on that one, you can. But here's the unit vector, here's the initial vector. Make sure the signs for both the a and the b values match. All right, letter K. So if we're looking at number 10, these are going to be some bigger numbers, but the process is the same. We want to know the magnitude of K. So square root of 16 is 196. Square root of, or 16 squared, 8 squared is 64. 196 and 64 is 260. Now, let me just double check. Oh, 16 squared is 256. My bad. That's why this is looking weird. 256. Go back and fix that. My apologies for that. I'm getting sloppy in my old age. 256 plus 64 is 320. Now, that one will break down. So 320, let's think about what perfect squares are going to go into 320. All right, we could try 16. Try 64. And 64 and 5 is actually probably the best one. So square root of 320 is 64 and 5, which is going to be 8 radical 5. So now the unit vector is just going to be the initial vector over that magnitude. So we have 16 over 8 radical 5, comma, negative 8 over 8 radical 5. Right away, I'm just going to reduce that to 2 over radical 5, and then negative 1 over radical 5. And then just rationalize those denominators. So 2 square root of 5 over 5, comma, negative square root of 5 over 5. So there's the unit vector for K. Now that one took a little bit of simplifying at the end, but again, the process is the same. This shouldn't be anything new. These are just kind of simplifying those answers so that they look in a presentable way. All right. Let's look at a couple more here. Now, these last two you might look at and be like, wait, I have 2 points here. But remember, I can always represent vector AB in component form first. Once it's in component form, it's the exact same thing. So think about AB. I want to know the magnitude of AB. Oopsie. I want to know the magnitude of AB. Well, let's think about what the component form for AB is going to be. 0, negative 7, and 6, negative 1. Well, you subtract A2 minus A1, which is 6 minus 0, which is 6. And then you subtract negative 1 minus negative 7, which is also positive 6. So the component form for AB is just 6, 6. So it'll be the square root of 36 plus 36. Square root of 72, which 36 and 2 is 6 square root of 2. So the magnitude of that is 6 radical 2. Now using the component form and the magnitude, I am able to write a unit vector. So it'll be 6 over 6 radical 2, comma, 6 over 6 radical 2. Does that make sense? I'm asking you as if you can answer me. So we go like this. So it's just going to be 1 over square root of 2, comma 1 over square root of 2. Then we rationalize square root of 2 over 2, comma square root of 2 over 2. And then number 12 is the same idea. Number 12, put it in component form first. So 8 minus negative 1 is 9. Negative 2 minus 4 is negative 6. So just like we did in the previous notes, you can just subtract the a's and subtract the b's, put it into that component form, and now we just find the magnitude of PQ. Square root of 81 plus 36. This one's going to be a little bit ugly, just because 117, believe it or not, does break down. 117 is 9 times 13, I believe. Let me just double check before I write something down. Yes, it is. So it'll be 9 and 13, which is 3 radical 13. That's one of those weird numbers that looks like a prime number, but it's actually not. Okay, that one throws people off. People leave that all the time. All right, so 3 radical 13, and then the process is the same. Put the component form over the magnitude, call it a day. So u equals 9 over 3 radical 13, comma, negative 6 over 3 radical 13. Reduce the numbers first, make that a 3, make that a 2. So let's see what we have here. So it's going to be 3 over square root of 13, comma, negative 2 over square root of 13, and then let's rationalize that denominator. So 3 radical 13 over 13, negative 2 radical 13 over 13. There's the answer, and there is the end of the lesson for today. I hope that this was digestible for you guys. I'm going to throw up some problems probably today, if not today, tomorrow morning for you to try on your own and turn in. So let me know if you have any questions.